In this CQPweb tutorial, we're going to be taking a look at the collocation analysis function. So I'm going to start with a fairly straightforward query. It's a lemma query for happen. Let's make it happen as a verb for the sake of argument. It's worth underlining that the collocation function works identically no matter what query you start with. So if you start with a query for a word, it will do collocations on that word. If you start with a query for a tag, it will do collocations on that tag. If you start with a query for a three-word phrase, it will do collocations on that three-word phrase. The system is entirely agnostic about what it is analyzing. The vicinity, so of course collocation is looking statistically at the vicinity of the query, so it is entirely arbitrary what you put here. Any search you like, you can run a collocation query on the results of it. So with all that said, let us run the collocation function. You'll see that first we get the options screen, which we've already discussed. For the sake of demonstration, I'm going to include everything, and I'll leave the maximum window span at ±5. All of this is explained in the tutorial on this proximity-based collocation options screen. So without further ado, let us go to the collocation screen itself. So here we are. This is quite a complicated display, so let's take a look at it and explain each aspect of it bit by bit. Let's ignore this control bar at the top here for now. We'll come back to that, so let me move down. And just let's take a look at the results table. So, first of all, you will see that you've got an explanation bar which is similar to the explanation bar at the top of a concordance screen. You'll see here actually that this bit at the end here, your query returned 1,788 matches. That's actually the exact same thing that you get at the top of the concordance screen. And like with the concordance, you get a time estimate. Generally, that's going to be bigger the more results in the query there were, because obviously the more results in the query there were, the more data there is to process to produce these statistics. So there are 2,996 different words in your collocation database. The collocation database is the database that is compiled of all of the words or the tokens around whatever you searched for. So what this means is that when the database was compiled around of the text from around my query for happen as a verb, then there were 2,996 different words in there, each of which is a potential collocate. Now, whether or not we want to accept that potential collocate as an actual collocate will depend on how we look at the statistics in the table below. So what happens is that these 2,996 different things are all listed in this table according to the statistics that are gathered for them. So let's take a look at this table. Let's look first just at this number one row here, the very top line. What fields of information do we have? Well, first of all, we have the number, which is an arbitrary number. It represents the ranking in the table being displayed right now. It doesn't represent anything other than that. Then you have the word itself. Incidentally, one thing to note is that the case here is arbitrary. When I say case, I mean uppercase, capital letters versus lowercase, small letters. What do I mean by that, saying that it's arbitrary? Well, when this database is scanned, all case versions of a given word will be combined together. So what with a capital W what with all capitals and what with all small letters, all of that will be combined together. Then what you see here is just one example, one version of it. So basically it depends on which occurs first in the database. So for what, the version with all small letters occurs first in the database, so that's the one that you happen to see, but this count includes all versions, no matter what the capitalization. On the other hand, if we jump down to number 10, where you see whatever, the capital W there, again, it's arbitrary. It just means that the first one in the database happened to have a capital W, but it includes all of the different versions. So capital W, small w, all small, all capitals, all variants. Okay. You see that this is a link, and if you hover on the link, it says show detailed information on what, show detailed information on to, show detailed information on it, so on and so on and so forth. We'll come to what you see when you click on that shortly. Total number in whole corpus is exactly what it says. It's the full frequency of this word. Now, if you searched in a subsection of the corpus, and frequency tables were available for that subsection of the corpus, then you'll get the frequency in the whole subcorpus instead here. But we searched in the entire corpus, therefore we see the frequency in the whole corpus. Why do we see this? Because when you do statistical proximity collocation, the score that a word gets is dependent on two things. It's dependent on how many examples there are in proximity to what you searched for, so happen as a verb in this case, versus how many there are in the whole corpus. Because if a word is really frequent nearby to your search, then that might mean it's a very important collocate. On the other hand, if it's a word that's generally frequent in the corpus, then that might not mean anything. So we always need this information of how frequent a word is in the whole corpus. The next column is the expected collocate frequency. What this means is, if the word what was spread evenly through the corpus, totally evenly, how many would we expect to find in the vicinity of happen, or whatever we searched for? And the answer in this case is 18.9. If those 12,000 examples were spread evenly through the corpus, then by chance alone we would expect 18.9 of those to be in the vicinity of happen as a verb. Well, obviously you can't have 18.9 examples in a place. It would be 18 or it would be 19, but this is the statistically expected collocate frequency. So that's expected. That's how many whats there would be nearby to the collocation node if it was spread out randomly, spread out evenly in the corpus. The observed collocate frequency is how many there actually are nearby to happen as a verb. So you can see that there are 554 examples of what nearby to happen, as opposed to 18.9 if there was no particular link between these words. There's obviously quite a big difference there, and therefore you would expect that to represent some kind of collocational link, and that is why it's at the top of the list. Now, all collocation statistics are based on a comparison of this number to this number. However, as we'll see in a minute, there are lots of different ways that you can do that comparison, and depending on how you do that comparison, you'll get different collocation lists. In the case that we're looking at now, you can see in the last column, which says log likelihood value, we are using the log likelihood statistic. The log likelihood statistic measures the amount of evidence that you have that the observed collocate frequency is different to the expected collocate frequency. So you can see that in the case of what, it's a very frequent word, and the difference between this and this is quite astounding. It's more than, about 30 or 40 times as big. So obviously there is tons of evidence, so you get a score of 2,721. Just to give you a guideline, the general rule of thumb in statistics is that you need the log likelihood to be either more than 3 point something or 6 point something or 16 point something for it to be significant, depending on the level of significance that you're going for. Obviously, in this case, we bust right through all of those thresholds. So this is a very highly statistically significant difference. The final column, well, not the final column, but the final one I'm going to talk about is this one here, which is the number of texts. This is important because high score in this column could be the result of what co-occurring with happen very, very frequently in just one text, or it could be the result of co-occurrence that happens evenly throughout the corpus. So let's take a look at this number here, 426 out of 1,000 texts in which happen as a verb occurs at all. So in half of the texts where happen happens, it co-occurs with what at least once. So there are 426 instances of what nearby to happen. There are 426 texts with at least one example of what nearby to happen. And if we compare the number of texts to the observed collocate frequency, then you can see that actually it's very spread out. This number is very close to this number. It's not that there's one text somewhere which has a huge number and then all the other texts have very few or none. We're looking at a really quite spread out phenomenon here. This is important because often, every text has its own subject matter, every text has its own idiosyncrasies. We do not want to take too seriously, if we're studying the lexical behaviour of a particular item, we don't want to take too seriously something that is just happening in one single text. We want to look at things that are generally frequent in the corpus. Now, there are ways of doing this statistically, but just doing an eyeball of this number versus this number versus this number is often enough to tell you whether or not a collocate is spread out enough to be interesting. Now, if we look down the list, you will see that because we are using the log likelihood value to score the collocates, everything is sorted in descending order of log likelihood. That means that the order for these columns is not necessarily descending. You can actually see that 2, the second item, occurs more frequently in the vicinity of happen because the observed collocate frequency is higher, and that happens in more texts. However, 2 is drastically more frequent in the corpus as a whole, 159,000, and therefore the expected frequency is higher, so the difference between the expected and the observed is not quite so big as it is with what. We do still have a very high amount of evidence because 2 is so frequent, and that adds up to a somewhat lower log likelihood score, but still one that busts through any of the standard levels for significance. So that's how to read this list. Let's now talk about what you get when you click on the links in this column and the links in this column. So let's start by clicking on the Show Detailed Information on What link. Okay. Now, again, you see at the top a reminder of what you're looking at. So we're looking at collocation information for the node, and there is an explanation of the query that we did. It uses CQP syntax rather than the simple syntax, but it's the same explanation of the query. And that's the word that we're looking at. What this screen does is 2 things. First, in this upper table, it shows you a list of all the different statistics. So on the previous screen we saw log likelihood, and as we'll see shortly, we can adjust the previous screen to show us any one of these other statistics. But on the previous screen we can only see one of these statistics at one time. On this screen, for a single word, we can see all of the statistics together. The dice coefficient, the log likelihood, the t-score, the z-score, the MI3, which is mutual information cubed, and the mutual information. I'll say a little bit about each of these when we talk about adjusting the statistic on the previous screen. But if you want a quick overview of how the different statistics compare for this single collocational link, happen as a verb, collocating with the word what, then that's what you get here. It says here value for window span -3 to 3. We haven't talked about window span yet. Again, that's one of the things that you can control on the previous screen. It will only show you the window span that was selected on the previous screen, which was in this case -3 to 3. But if I adjusted the window span on the previous screen and then clicked on the link, I'd get a different window span here. Now, some other tools, perhaps the most notable one being Wordsmith, very famous corpus analysis software, automatically tells you when you do collocations where in relation to the node each of the examples occurs. In CQPweb you have to click into this detailed information screen to see that, but that's what the lower half shows you. So in this bit of the screen we have a reminder of the expected frequency, the number of texts in which it occurs, and how many raw instances there are. That's all information we saw on the previous screen. But then we have a table breaking down where it occurs relative to the node. So remembering that we're looking -3 to 3, so that's 3 tokens before to 3 tokens after. For each of those slots we now have a count of how many examples of what occur there. So for distance -3, we have 51 examples of what. -2, 267, -1, 225. And again, we have the breakdown of the number of texts. After the node, we have far fewer. None one word after. Two words after we have 8, and 3 words after we have 3. If we look at the number of text column, again we can see that these numbers are very close to these numbers. So that means that all of these patterns are nice and spread out in the corpus. None of them is bunched in a single file. And this expresses this column as a percentage of the total. So you can see that these two are each just under half. Well, this one's just under half, this one's about 40%, and then the others are much smaller. So this gives us an idea of the kinds of phraseologies that are happening in what we're looking at. So here it's what something something happen. This is what something happen, and this is what happen. Conversely, this one is happen something what, happen something something what. Each of these links, if you hover on it, it says show solutions collocating. So let's take a quick look at that. If we want to see examples of what one word before, we click there. And voila, this is a standard concordance display with the node in the middle, except that we have the collocating item highlighted in the context by being made bold. And this includes only the examples from the previous query that have what in this position. And so you can see that there are only 225 hits in this query as opposed to the original 1788, because we have gone through a collocation thinning process. We have thinned it to just examples of what in position -1. Now this is a query like any other query, so you can do all the things that you would be able to do with this query. All the things that you would be able to do with any other query are available here. I've done a separate tutorial on the concordance screen and separate tutorials on all of these things, so I shan't go through them again. Just note that this is possible. You can do any kind of analysis that you can do on any query can be done on one of these collocation thinned queries. However, let's not worry about that for the minute. Let's go back and let's try another one. Let's try what something, happen something what, of which there are far fewer examples. And there you can see they are. And most cases, the thing between is a punctuation mark. In 2 cases, it is and. But in all cases, the what is in a different clause to the happen, so that again tells you something about the phraseology. Okay, so that explains that screen. Now, if you want to see the examples of what alongside the happen node, regardless of what position it's in, that's what the link here does. So if we click on this link in the observed collocate frequency column, it hums away for a while, and then gives us the concordance. And you can see that in this case, the whats are occurring at all kinds of different distances from the happen. So you have some before, some after, some immediately before, some at a distance, so on and so forth. And again, all the usual things you can do with a query, you can do here. Shan't labour that. Let's just go back. So, that explains this collocation table. Let's just scroll down to see what there is. By default, you only see 50 at a time, but you can always scroll forwards just as you can with most CQPweb page displays, and you can keep going on and on down the list. You can see that the log likelihood values are getting quite small. These are things that we would generally not think are collocates because there's not enough evidence to say that there is a link. So for instance, here we're up to your. In the case of your, the expected frequency is 8.9 and the observed frequency is 11. So these are very low numbers to begin with, and also there's not much difference between this and this. So that means that there is practically no evidence for a link, and therefore the log likelihood goes down to 0.4. Let's keep going. Now, the log likelihood actually goes into negative numbers. Those of you who know anything about statistics will know that log likelihood never actually goes into negative numbers. What it means when log likelihood is shown going negative here is that we are starting to get evidence for a link in the opposite direction. That is anti-collocation, if you like. These are things that are avoiding the node. So man occurs less frequently than we would expect, but again, not much difference between expected and observed, and the numbers are tiny anyway, so not much evidence. But as we go down in the negative numbers, we're getting more and more evidence for avoidance. So we're starting to get actual evidence for it being less frequent near to happen as a verb than it is in the rest of the corpus. Expected frequency 42.6, observed frequency 16, and if we keep on going we will get the strongest negative collocations. The and of seem to have the strongest scores here, the log likelihood going into the hundreds. This is generally true of the collocation display, that you'll get words that are attracted to the node at the top, and then as you go right to the bottom you'll get the words that avoid the node. Now, usually we're much more interested in the words that are attracted than the words that avoid, but it's worth noting that that's what happens as you get right down to the lowest numbers. Okay, let me go back up the list. So here we are on the first page again. So that's a guide to what we see here. Let's talk about some of these controls. These controls allow you to do a number of different things with these controls allow you to do a number of different things with the collocation table that you see here. So let's talk about them. First of all, let's talk about this control here. This control is your main trigger for doing things from this page. So let's just look at these two items here. Back to query result is exactly what it says. It takes you back to the query from which these collocations were generated. I shan't show that because that's obvious. New query takes you quickly back to the front page Submit change parameters is what you use if you change anything in these controls here. So for example, if we change this or this and we want to update it, then we just click submit change parameters go. We'll talk about that in a minute, but let me just set everything back to what it was. Download collocation results is an interesting one because of course you've only got 50 results on any given screen. Sometimes you want to see all of them, or store them on your own computer so you've got a record. In that case, you can press download collocation results, and after it hums away for a while, you will get a text file download, which I shall open. And if I drag in my text editor into the screen here, then you can see that what has been downloaded is a text file which contains roughly what you would see in the collocation screen, but you have a full list going right the way down to the bottom. So you can see it goes right the way down to the bottom negative values that I showed you several pages down. You've got the same columns, the number, what the collocate is, the total number in the whole corpus, these are the raw headers here, the expected frequency, the observed frequency, the number of texts, and the statistic, in this case log likelihood. So this is exactly the same as you see, except that it's just a plain text file with the columns delimited by tab characters. So here in the header row, there is a tab between each header. Here in the actual rows themselves, there is a tab between each line. This isn't terribly readable, but if you copy and paste it into a spreadsheet program, so Microsoft Excel or whatever you prefer, or if you save it in a database program, then the columns should be recognized automatically, and this is a convenient way to save the results. And you have the header line up here to remind you of exactly what it is you're looking at. So the download function is for if you want to save it or if you want to do detailed analysis of this table on your own computer. And the table that you download, you can twiddle the settings for in the same way that you can twiddle the settings for the table on the web, which I'm about to demonstrate. So, these settings. Let's take it from the top, shall we? And talk about collocation based on. Collocation based on allows you to switch from searching in your collocation database for co-occurring words, which is the default, to any of the annotations that you ask to have stored in the database. So let's try switching from word form to part of speech tag, which is one of the most important annotations. So submit change parameters, go. And there we are. We have in this column here, you can see it no longer says word, it now says part of speech tag, because we are looking at this annotation layer for the statistical collocation instead of looking at the word layer. So each of these is a tag found in the corpus, and this particular corpus was tagged with the clause 6 tag set, so these are tags from the clause 6 or C6 tag set. You can do all the same things once you've done a collocation based on annotation, as you can do with a collocation based on words. So you can see the detailed information. So DDQ represents interrogative and relative determiners. So this includes what, for instance, which was the top word collocate. And again, you can click and get detailed information, or you can click and get the information here, and you can see that the word again that is collocating is highlighted, and it includes lots of examples of what, which we'd expect because what was the top word collocate, but it also includes collocation with other words that have that same DDQ tag, such as which there in the second line. PPH1, well, that's going to be boring because that tag only applies to the word it. Let's find one that's likely to be interesting. VM, modal verbs. Let's see that. Ah, yes, lots of different ones here. Would, could, might, should. Now, any one of these verbs individually might not be a terribly strong collocate, but once we use the tag to group them together, then we see that there might be a strong collocational link with the category that doesn't exist with any of these individual words. In some corpus analysis tools, this is called colligation. Colligation meaning a link between a node and some aspect of grammar that co-occurs in the context. We don't use the term colligation in CQPweb, however, because as far as we're concerned, colligation is a theoretical term which applies to a particular interpretation that you make, whereas what we're actually looking here is not colligation particularly, it's collocation, proximity collocation with a particular part of speech tagging scheme. But you will see collocation with part of speech tags referred to as colligation in the literature sometimes. Okay, so let's try another one. Let's try with lemmas. Now, for English, collocation with a lemma is going to be very similar to collocation with a word because English doesn't have very complex inflection, but in languages with complex inflection, collocation with a lemma is often more enlightening than collocation with a word. For example, a language like Arabic, where each lemma has a couple of dozen inflectional forms, you won't have statistical power to detect links with individual word forms, but you will have statistical power if you look at lemmas. But again, as I said, in English, the list here is very similar to the list we saw for words. You can also do semantic tags if your corpus happens to have them, or whatever other form of annotation your corpus happens to have. Let's look at one example. T113 in the USAS scheme, which is the scheme we use for semantic tags in this corpus, includes words relating to something to do with time. Ah, yes, so you have going to, one day, will, future, other words, about to, going to, yes, all kinds of things to do with that coming up under that tag. So whenever you do collocations on any kind of tag, whether it's a part of speech tag or a semantic tag or a lemma or whatever happens to be available in the corpus that you're working with, going to a concordance of it will always bring you up a concordance for a group of words, the group of words that is annotated according to the scheme here. And of course, if you don't remember what the tags mean for any particular scheme, semantic tag or part of speech tag or whatever, then there is the link to help down here at the bottom, which will take you to, assuming that your corpus is set up to give you the appropriate help, then that link will take you to it. So that's this. That's this option, collocation based on. Let's go back to word form and talk about the next option, which is statistic. Now, the default statistic is log likelihood, but there are lots of other statistics available. In fact, there are 7 available. 6 of them are different statistics that are commonly used in the corpus linguistic literature for collocation. Now, if you know about collocation in the corpus linguistic literature, you'll know that actually dozens and dozens and dozens of different statistics are used for collocation, but these are the 6 most common. And then in addition to that, you have rank by frequency, which doesn't use any kind of specialized statistic. It just sorts the table according to the observed collocate frequency. Now, depending on which statistic you choose, they all have different features, but you'll get a different list. You'll get a different ordering depending on which one you choose. Let's take a look at rank by frequency. Rank by frequency doesn't actually have a collocation statistic column. As I said, it just sorts by the observed collocate frequency. Not usually terribly interesting. Log likelihood is the one we saw before. It's, as I said, commonly used but often criticised for giving low scores to things that are individually rare and therefore emphasising function words. Another popular statistic that does a similar kind of thing is the t-score. The t-score also tends to emphasize function words, as you can see. Now note that whatever statistic you're using, it'll be named here and it'll be used to sort the table, as you can see here. All the statistics are on different scales, so you must remember that these scores are, each one is on its own scale, and so you can't compare t-scores to log likelihoods, for example. That wouldn't make sense at all. But we have uh, we have a top t-score of 22 here, where it was, for log likelihood, it was, I can't remember exactly, it was a couple of thousand, I think, wasn't it? Yes, so t-score, as I said, also tends to emphasize um, high frequency items. Mutual information is at the other end of the scale. It tends to emphasize low frequency items where there is a big difference between the expected and the observed. So here you can see that whatever, which is the top here, is not especially frequent, but the observed frequency is just, what, about 30 times as big as the expected, and so it gets a very high mutual information value. So yes, so that's about 30 times as often. That's about just under 30 times as often. That's, again, very, very high frequencies, very, very high multiples of this times this, but the absolute numbers are low. So that's why people often prefer mutual information when they're not interested in function words, when they're interested in content words. Because mutual information, however, often puts things with very little evidence high up the list, people often prefer some of the intermediate measures which don't emphasize content words, low frequency content words, as much as mutual information does, but neither do they emphasize high frequency function words as much as the t-score and the log likelihood. And all the other statistics that you've got here, mutual information cubed, z-score and dice coefficient, do that in different ways. So if we take a look at the mutual information cubed, without going into the mathematics of it, mutual information cubed is calculated in the same way as mutual information, but with a tweak to give more emphasis to the underlying frequency. So you can see here that this favours high frequency items a bit more than the mutual information does. The z-score is a kind of significance test, which usually has the outcome intermediate between the log likelihood and the mutual information. And then the dice coefficient is a measure which often has similar effects to the z-score. I shan't go into the mathematics of any of these. Different people, it should be emphasized, different scholars in the literature prefer different tests. Depending on who you read, you will see different tests emphasized. But let's go back to z-score, and let's stick with z-score for the rest of this tutorial, because, as we said, z-score is a nice intermediate statistic. Doesn't emphasize what's frequent as much as log likelihood does. Doesn't emphasize what's infrequent as much as mutual information does. Okay, let's take a look at the next line in this control table. This line controls the collocation window. Now remember that when you first come to this screen, you build a database of the items around the node, and when I built my database, I built it from 5 to the left to 5 to the right. However, we don't always use all of that window, and you can see that by default here I'm using a window from 3 words to the left to 3 words to the right. This is completely controllable within the bounds of what I decided on the previous screen. So for example, we could adjust it to 4 to the left, 4 to the right, which is the classic recommendation stemming from John Sinclair's work in the early 70s. Or we could change it to be the full 5 to the left, 5 to the right, that is the entire thing. And you'll see that when we change the boundaries, the numbers here change. Because of course, if we widen things out from 3 words each way to 5 words each way, then there's going to be more, the observed frequency is going to be higher because more examples are caught within that scope. So if I click on the link for what, this time we'll see examples of what that are more distant from the word happen than any of than the whats were when we did it with just 3 words each way. And this will also change the z-score or whatever statistic you have here, because again, all of these collocation statistics are calculated using some formula that is based on the observed and the expected frequency, and therefore if you change these, then this will change. Usually not too much, you would hope, but maybe radically. Another thing that you can do is that you can use these controls to look just at one position. So if we're interested in what occurs 1 to the left, then we can say look from 1 to the left to 1 to the left. So just look at that single position. Okay, quite similar, but the observed frequencies have gone right down. So if we click on what, then we just get the ones that are 1 token before, none of the others. Try it again with 1 to the right to 1 to the right, just to look at what comes after. Now we noted, remember, when we looked at what on its own, that what doesn't come afterwards. The most frequent thing one word after turns out to be to, which seems to be the phraseology happen to. And again, we can get a concordance of that. There it is. That's quite nice. No, I want to go back, don't I? Yes. Okay, so let's just adjust it to 4 out of 4 while we explore the rest of these controls. The next line in the controls are your filters. Frequently, or well, usually is perhaps the better word here, we are not interested in node collocate pairs that occur very infrequently. So what this lets you do is filter out anything that does not occur enough times. So for instance, if you're not interested in any node collocate pair that occurs less than 10 times, you can set this to 10. If, on the other hand, you want every single node collocate pair, no matter how infrequent it is, you can set that to 1. The notation here, frec node comma collocate, means the frequency of the node and the collocate co-occurring, and then in this column, frec collocate, that means the overall frequency in the whole corpus of the collocate. So this corresponds to this column. So this says the number in this column must be at least 5, and this corresponds to the observed collocate frequency column and says that that must be at least, well, 5 or whatever. If there is a node collocate pair that does not meet these conditions, it just won't be shown in the table at all. It will not be there. It'll just be absent. Now, the default setting of both of these being 5 is fine in most cases. The exception is mutual information. If you're using mutual information, then the recommendation in the literature on corpus statistics is that you should set these two to be a bit higher. It should be set to be at least 10 because, as we've said, mutual information tends to highlight low frequency things, and if you put in decent floors, that's what they're called, frequency floors, that's what they're informally called, then that tends to counteract the worst of that, if you like. It tends to get rid of the ones with the tiniest frequencies. So if I press go, you'll see, looking at the observed frequency here and the total number in whole corpus here, we have reduced the number of infrequent items that pop up due to mutual information. And again, we can take a look at some of these. So here's something interesting about mutual information. What kept on popping up as the top item for most of the rest, but for mutual information, you can see it's highlighted accident, whose absolute frequency is much lower, but its mutual information score is quite high. And there we are. Accident happening, happening in an accident, happened by accident, so on and so forth. So that's the collocation controls. We can also filter the results by other factors than the frequency floors here. Let's talk about this box here, which is the tag filter. The tag filter applies to the primary annotation. The primary annotation is usually a part of speech tag, and what happens is that you will get here a list of all the codes that appear in the annotation level for your primary annotation, which in this case is a part of speech tag. And as I said, this corpus happens to have the C6 tag set, so what you have here is a list of all the tags in the C6 tag set. So what you can do is you can pick one. Let's pick DDQ, since we were looking at that before. The tag appears here. You can also type a tag directly if you want, so there I go, DDQ. Either way, it's exactly equivalent. And what that will do is filter the list down to just the items that have the tag in question. So there's what and there's which we saw. We saw both of these when we did the tag collocate for DDQ. Let's take a look at that. There's all the whiches. We've already looked at what's. So that's something that we can do. The other thing that you can do here is that you can filter according to a specific collocate. So if there is a specific word that you're interested in, you can type it here. I'll type accident, and that will take you straight to the detailed information screen for the word that you typed in. So that's a shortcut, really. It means that you don't have to search through the list. You don't have to go through the entire table to find a word that you're interested in. You can just type it in there. Obviously, if the word is near the top of the list, it's quicker to click the link. If the word is somewhere way down the list, buried several pages away, it's quicker just to type in the word there. Okay, that is pretty much everything that you can do with the collocation controls for proximity collocations. It's quite a complicated function simply because collocation is a procedure that has so many decisions to make, from what you're going to base it on, what statistic you're going to use, what window you're going to use around the node, all of these things. That's what makes this a complex procedure. It's what makes it a very variable procedure, and that's why you've got so many choices in CQPweb. But if you understand a bit about these choices, then you'll be able to make effective use of this control. That's it for this tutorial. Thank you for your time. Thanks for listening.